We're going to start the next topic of the same chapter. Chapter is metals and nonmetals, and today's topic is reaction of metals and nonmetals. We already know that what are metals and what are nonmetals. So whenever metals react with nonmetals, they form a new compound. Basically, when metals reacts with nonmetals, they form salt, but there is a bond in between them. So metals always combine with nonmetals, forming an ionic bond. So when metals react with nonmetals, they form ionic compounds, and when nonmetals react with the other nonmetals, they form covalent compound. I would like to tell you more about this with the help of your NCERT book. So in your book, there is this table 3.3. In this table, you have been given about noble gases, metals and nonmetals. So, noble gases are those elements which have completed their octet structure, or we can say that which have complete electrons in their outermost shell. Whereas metals, as we can see here, have 1, 2 or 3 electrons in their outermost shell. And in the case of nonmetals, we can see that nonmetals have either 5, 6 or 7 electrons in their outermost shell. A carbon is a non-metal, but it has 4 electrons in its outermost shell. It is also a non-metal. We will be studying about carbon in detail in our next chapter, that is chapter number 4. But in this chapter, since we have to study about only metals and non-metals, so we will be dealing only with these metals and non-metals. So, before we start, I would like you to explain a little about noble gases. Now, noble gases like helium, neon and argon, as you can see here in the top, is having 2 atomic number of helium. Then neon is having 10 atomic number and argon is having 18 as an atomic number. So if the electronic configuration we're gonna see is that KLMN, you already know that we have studied in class 9 and you know how to make this. So without wasting much time on this, I would like you to explain in a little bit that helium, neon, argon, in all these 3 elements or in these noble gases, we see that they are having the equal number of electrons which are supposed to be in the outermost shell. Like helium is having only one shell, that is K shell, and number of electrons in the K shell is 2. So maximum number is 2 and it is having 2 electrons in its outermost shell. That is, the octet structure is complete. Then neon is having 2 and 8. So K and L shell. So L shell has maximum number of 8 electrons and here are 8 electrons already. So that means its octet is also complete. And then argon is having 2, 8 and 8. So it's also complete. So these gases do not want any other electron to complete the octet structure. Neither they will donate the electron because they don't have anything to give or to gain. So they are self-sufficient. That is why they acquire a noble gas configuration and we call them noble gases. That means they do not react with any other element, either non-metals or metals. But these metals and non-metals are little different. Like they have 1, 2 or 3 electrons in the outermost shell, or here 1 or 2. So they also want to attain these noble gas structure. They want to become like these gases. Since these sodium, magnesium, aluminum and potassium, they are having 2 and 8. So 1 is extra here. In the case of magnesium, 2 is extra, and in the case of aluminium, 3 is extra. So none of the element gonna give 7, 6 or 5 electrons to these metals. So in order to attain the nearest noble gas structure, that is of neon, they will donate their 1, 2 and 3 electrons. And in the case of potassium and calcium, they will donate their 1 and 2 electrons and they will attain the noble gas structure of argon. So that is why metals always donate the electrons, because they have 1, 2 or 3 electrons extra. Because gaining 5, 6 or 7 electrons from any other element, it's quite difficult because nucleus hold a charge. So because of the positive charge in the nucleus, it won't allow the electrons to move out. So but 1, 2 electron can be moved out, so it will donate the electron. Whereas in the case of non-metals, they are lacking 1, 2 or 3 electrons from their outermost shell. Like they want to attain the noble structure of neon, because neon has 2 and 8. So in its L shell, they want to have 8 electrons, because here in the L shell, the number of electrons should be 8. So these are having 8, 8, so they can donate the electrons, but this is having 5. So they need 3 electrons. That is why they will like to gain 3 electrons. And oxygen having 6, again it wants to have 8, so it will gain 2 electrons. In the case of fluorine and chlorine, they will have 1 electrons vacant, so they will gain 1 electron. So the structure would be just K and L, so they just need 3 electron here, 2 here and 7 here. So it will acquire the structure of neon. In the case of phosphorus, sulfur and chlorine, they will attain the noble structure of argon, because they want to have 8 electrons in the outermost shell. So they will accept 3, here 2 and here 1 electron. So this is the reason they donate and accept the electron. Now metal, here we can see that sodium has 1 electron extra, and here chlorine has 1 electron less. So sodium will give 1 electron to chlorine. That means there will be transfer of electrons. So when there is transfer of electrons, they are called as ionic bond. This we're gonna study in this chapter. I hope it's clear. So before I start, I would like you to again revise with the terms which you have already read in your class 8th and 9th. But again, I would like you to have a quick revision. Like ions, if you forgot, here again I've written an ion is an electrically charged atom. Now whenever atom either donates or accepts any electron, become charged. So when it acquires a charge on it, we call it an ion. Cation is a positively charged ion. So when any atom donates any electron, it becomes ion, but it becomes a positive ion. So for the positive ion, we have a term which is called as cation. Same anion, whenever an atom accepts the electron, it becomes negatively charged. So a negatively charged ion is called as anion. These terms you should always remember in your mind. So please by heart it. Okay, now what is the cause of chemical bonding? As I've already told you, the cause of chemical bonding is to attain the nearest noble gas configuration. So the atom combines with one another to achieve the inert gas electronic arrangement and to become more stable. Because these gases are stable, so these atoms which are nearby these atomic gases, so noble gases, so they want to acquire the electronic configuration of these gases. So that is why they exchange the they transfer the electron, like they donate or they accept the electron. So here an atom can achieve the inert gas electronic arrangement by 3 ways: either by losing 1 or more electron like metal does, either by gaining 1 or more electrons like non-metal does, or by sharing. So sharing is done by carbon, and there are many other non-metals which share their electrons. So we're going to study in the next chapter, but in this chapter we will be just dealing with these 2 things. Now, formation of positive ion, as I've already explained you, but again I will explain you. Like if an element has 1, 2 or 3 electrons in the outermost shell, then it loses its electron. We all know that magnesium, example magnesium here is having 2, 8 and 2. This is K, L and M shell. So in the K shell it's having 2 electrons, in the L shell it's having 8 electrons, and in the M shell it's having 2 electrons. So it wants to acquire the electronic configuration of neon gas. That is why it will donate its 2 electron. So it will acquire a positive charge of 2, because 2 has been given from this, so it will have a 2 positive charge. so it will become an cation. Okay, so it will call it magnesium ion, which will actually dissolve this shell. There will be no M shells, it will be only K and L shell. Same in the case of aluminium. Like aluminium is having just K, L and M shell, and in the K shell it's having 2 electrons, and in the L shell it's having 8 electron, and in the M shell it's having 3 electron, because the aluminium has 13 atomic number. Okay, so 13 atomic number. So now what will happen? Now this aluminium will donate its 3 electron and will become positive ion, that is cation Al, and it will have 3 plus charge. Okay, so it will be aluminium ion, and it will have only in K shell and in L shell 2 electron here and 8 here. Okay, so in the case of sodium again, now sodium, we all know that it is having atomic number of 11. So 11, so this sodium will donate its 1 electron, because sodium is just having like K, L and M, 2, 8 and 1. So here only 1 is the extra, so it will donate only 1 electron and it will acquire a positive charge of 1. So we don't need to write 1, so it will just plus here. It will be sodium ion. So now its configuration would be like this: K and L. There will be no M shell, 2 and 8. Okay, I hope it's clear now. So now again, how the negative ions are formed. In the case of negative ion, they will accept the electrons. So as in the case of positive ion, they were having, or they were just giving the electrons, but in the case of negative ion, they are accepting the electrons. So if an element has 5, 6 or 7 electrons in the outermost shell of its atom, then it will gain electrons to achieve the stability or to attain the nearest noble gas configuration. So like formation of chloride ion, when chlorine accepts the electron, we don't call it chlorine ion, but we call it chloride ion. Same in the case of hydrogen, if you remember, when hydrogen accepts the electron, we call it hydride ion, and when it donates the electron, we call it hydrogen ion. In the case of chlorine, it is having K, L and M configuration, and here it's 2, 8 and 7. So in the outermost shell, that is M shell, it is having 7 electrons, because the atomic number of chlorine is 17. So because 1 is missing, so it wants to acquire the nearest configuration of the noble gas, which is argon. So it will accept 1 electron plus, so it will become a chloride ion. It will have minus charge, 1 minus charge. Now the configuration will be 2, 8 and 8. Same in the case of oxygen. Now oxygen will become oxide ion. It will have 2 negative, because oxygen is having atomic number 16. So oxygen will accept 2 electrons. So after accepting 2 electrons, it will become oxygen minus. That is, the configuration of oxygen was K and L. It was 2 and 6. After this, it will become 2 and 8. So 8 is complete. So it has gained the electronic configuration of neon. So now it's stable. That is why it will become a negative ion, which we call as anion. Same in the case of nitrite. So now when nitrogen become ion, we don't call it nitrogen ion, but we call it nitrite ion. So in the case of nitrite ion, again, like nitrogen is having atomic number 7. So nitrogen will gain, okay, first we'll write configuration K and L. So in the K shell, it has 2 electrons, and in the L shell, it have only 5 electrons. Okay, but it wants to have 8 electrons, so it will gain 3 electrons. So here will be 3 electron it will gain, so plus, and it will become a nitrite ion, after gaining 3 electrons. Okay, so we'll call it nitrite ion. Okay, 3 minus, and the configuration now will be Kl, like 2 and 8. I hope it's clear. Okay, so this is also done. Now formation of, why does it happen? Formation of negative ion, formation of positive ion, it's all clear. So after this is clear, we're gonna move next to the electron dot structure. Now electron dot structure is very simple, that is the valence electron in an atom are represented by putting a dot on the symbol of the elements, like 1 dot for each valence electron. So in any valence electrons which we are studying here, like in the case of sodium, we represent the number of atoms, the number of electrons which are present in the outermost shell are represented by a dot. Like if we are talking about sodium, so sodium is having only 1 electron in its outermost shell, that is 1. So we are representing here it from 1 dot. In the case of magnesium, we are having 2 electrons in the outermost shell, so we are representing here by 2 dots. In the case of aluminium, we have 3 electrons in its outermost shell, so here are 3 dots. Potassium having 1, so 1 dot, and calcium having 2, so 2 dot. This is how we explain this dot structure, because we already know that you have to learn the atomic numbers. You have already learned in your class 9. If you haven't, now please learn it. So when you know the atomic numbers, you can easily write the electronic configuration. By its help, you know how many valence electron are there in its outermost shell. So according to that, the number of valence shell in the outermost the number of electrons in their valence shell, we mark these dots. So in the case of non-metals, it's very easy. Like chlorine, we all know that is having atomic number of 17, and according to 17, its atomic configuration should be, electronic configuration should be 2, 8 and 7. So there are 7 electrons in its outermost shell. So here I've made 7 dots, 1, 2, 3, 4, 5, 6, 7. So this is the electron dot structure of chlorine. Oxygen is having 2 and 6 electrons, so 6 is the number of electron in its outermost shell, so 6 here. Sulfur is having again 6. Okay, now sulfur's electronic configuration is somehow 2, 8 and 6. So 6 is the outermost shell. This 6 is not the outermost shell. M is the outermost shell, so having 6 valence electron. So here 6 dot. Again, there are few more, like nitrogen. Nitrogen is having the atomic number of 7, and according to that it would be 2 and 5. So it has 5 electrons in its outermost shell. So the structure would be like this: N and 2 dot here, and 2 here, and 1 here. So 5 electrons. Then again after that fluorine. Okay, fluorine has having this 2 and 7, because it is having atomic number of 9. Paper is moving. Okay, so now it will have 7 electrons, same like chlorine, because chlorine and fluorine are from halogen family. So here this is the electron dot structure of metals and non-metals. Okay, now after this, now we move to our main topic, that is chemical bonds, the thing which we want to study. So now there are 2 types of chemical bonds. One is ionic bond and the other one is covalent bond. Now this covalent bond I will teach you either in chapter number 4 or the same chapter once we finish this topics, because about covalent bond we have to study in chapter number 4 in carbon and its compound. So we want to study about this ionic bond. So ionic bond are the chemical bonds which are formed by the transfer. Remember the word transfer here, because there is transfer of electrons. When we call sharing, so sharing can only be termed in the covalent bond, because sharing is done there. But in this case we don't do sharing, They don't do sharing, they transfer the electron from one element to the other element. Okay, so in the ionic bond, there is transfer of electrons from one atom to the other, known as ionic bond. So now first we gonna study is formation of chloride, sodium chloride. Okay, so sodium chloride here, in the beginning of the topic I have told you that we are studying reaction of metals and non-metals. So if you see here, sodium is a metal and chloride, that means chlorine became chloride here, is a non-metal. So this is the reaction of actually metals and non-metals. So sodium here is a metal, and sodium I have made one dot, that means it represents the electron dot structure of sodium because it has 2, 8 and 1 electron in its outermost shell. So one electron is having one dot here, and sodium always donate the electron. So sodium will donate the electron and will acquire a positive charge, and the configuration would be 2 and 8. In the case of chlorine, I have used the another pen. So chlorine is having 7 dots in its outermost shell, that means its configuration is 2, 8 and 7. So 7 electrons, so it wants 1 electron, so it will gain 1 electron, so it will become 2, 8 and 8. So it will become stable, and this will also become stable. But where it will give this electron and from where it will get the electron, so they will transfer the electron to each other. So sodium will give its 1 electron from its outermost shell to this chlorine, so it will transfer the electron from here to here. Because this transfer will be done, so they will become close and they will form a bond between each other, which we call as an ionic bond. So this is another atom and this is another atom. Two different atoms are here, metal and non-metal. So they will combine together, they will come close together because it will give 1 electron to this, and to take the electron it will come close to sodium and it will be having a bond between each other, which we call as an ionic bond. So here after the transfer of electron, this is called as transfer of electron. Transfer of electron. Okay, now it will become now sodium ion because it has donated electrons, so it will become positive ion, and it has accepted the electron, which we call as a negative ion. So it will form a ionic compound. It is called as ionic compound. Okay, or we call it NaCl. In your book also it's here. So in the book you have been given like this is cross here, so they have made this cross. This is also very simple. You can also write like this method, like you are representing one by dot and the other by cross, so that there will be no confusion. Like if you see here, there is one dot is from sodium and the 7 electrons are from chlorine. So 7 plus 1 becomes 8 and it becomes stable. So both of the atoms become stable and it forms a stable new compound called as sodium chloride, which we call as salt in our language. And common salt is having a very high boiling and melting point because ionic bonds are very strong bond. Okay, so we're gonna study about few more examples. Like we take potassium chloride. Okay, potassium chloride is we know that okay, potassium chloride. Now potassium is K, okay, and chlorine is Cl. So I am writing here cross, okay, so that you can easily understand it. I am not explaining you all the things which I have done in the previous, because here I've explained you in detail, but I will just move like this. So now this is having 7 electrons and it is having 1 electron, so it will just donate its 1 electron here, so it will become potassium ion, positive ion, and it will become like chlorine ion. So it will have cross here, all the 7 electron and 1 dot. Clear? So we can call it a KCl. It's a new compound. So this is an ionic compound. The other example, let's take magnesium chloride. Magnesium chloride. Okay, we all know magnesium is Mg. Mg is having 2 electrons in its outermost shell, so it will donate 2 electrons and will become magnesium ion. If I'll show you like this, so it will be like this. It will just donate 2 electron and it will become magnesium ion 2 plus. So if we'll see the configuration, it would be 2, 8 and 2 in the beginning, K, L, M, N, but in the when it becomes ion, it will be 2 and 8. So magnesium ion. And chlorine, we all know that. Now here, if you'll see that magnesium is donating 2 electron, but here is chloride, and chloride only need 1 electron to attain its electronic configuration to become stable. So magnesium is giving 2, but chlorine wants 1. So magnesium will find 2 chlorine atom to give 1 electron to both of them. So 2 chlorine atom will come here, and these 2, so it will be cross. I'll just make cross so that no confusion will be there. So these 2 chlorine will take 2 electrons. I hope it's clear to you people. Don't get confused with this 2, because when we write 2 here in the front of any element, so atom, it means that there are 2 number of atoms. So 2, and this is having 7, so it will become 1 here. Okay, negative 9. Now it's 2, 8 and 8. It was 2, 8 and 7 in the beginning. This is how. So how it will actually happen, like this will be magnesium, okay, having 2 electron, and it will combine with 2, because 2 here, 2 chlorine. One this and the other one is 7. Other one is this. Okay, so it will give 1 to here and 1 electron to here. So 2, and it will become Mg 2 plus, and this Cl and here also 1 Cl. Or we can write like this, Mg 2 plus or 2 Cl. Okay, I hope it's clear to every one of you. Or we can write like this, Mg Cl2. Yeah. So one more example we will be taking. Okay, so we'll be taking now magnesium oxide. Okay, magnesium oxide. So this magnesium oxide, we know that magnesium is having 2 electrons and oxygen wants again 2 electrons. So oxygen is having this structure, 2 are missing, so magnesium will give 2 electrons, simple. So it will become to the same here, it will become Mg2 plus, and here it will be oxygen, 2 dots for magnesium, and here 2 minus, because magnesium had 2 electrons in its outermost shell and oxygen have 2 less electron in its outermost shell. So one magnesium atom will give 2 electron to one oxygen atom. So only one oxygen atom will combine with one magnesium and it will become MgO. MgO. Now one more example we'll take sodium oxide. Okay, now sodium oxide is sodium oxide. Okay, now sodium oxide is sodium Na, and we know that Na is having only one electron in its outermost shell. So one Na will be just giving one electron to the oxygen, but we know that oxygen wants 2 electrons to complete its octet structure. Since oxygen is having 6 number of electrons in its outermost shell, so this oxygen needs 2 electrons, but this is only one sodium. So this sodium will combine with we will use 2 sodium to combine with 1 oxygen. We need 2 sodium. Okay, so there will be transfer of electron from this to this. So it will become 2 Na plus, and oxygen will be simple. Oxygen will become dot dot from 1 Na and from 1 Na here. I hope it's clear to you people. If you have any doubts, you can ask me. So we will be like this, Na2O, because it's 2 here, so it will be Na2O. This is how we write. Okay, so this is the formation of ionic compounds. In the next lecture, we will be reading about what are the properties of ionic compounds, which is very easy. So till then, please practice these all the things which I've taught you, and if you have any doubt you're going to ask, I think it's simple. It would be clear to you how this is done, and the same thing which I've explained you here, it's given in your book like this. This magnesium, which you can see is having 2 extra electrons in its outermost shell, so it will donate 2 electrons, and chlorine wants 1 electron. So since chlorine wants only 1 electron, so it will use 2 chlorine to give its 2 electrons. So 1 will be given to this and 1 will be given to this chlorine, and it will form magnesium chloride, that is NaCl2. But in the case of sodium oxide, so there is only 1 electron in 1 sodium atom, but oxygen needs 2 electrons. So 2 sodium atom will combine to give 2 electrons, so 1 from this sodium and 1 from this sodium, so that it will also become stable, and these also become stable, so it will form a new compound called sodium oxide, which is Na2O. Okay, so I think it's all clear to you people. So please study and go through all these things which I have taught you today. I hope it's easy and it's clear to you, but if still you have some doubts or some problem, feel free to ask me. I will be helping you out, and please study all these things, and please study your book thoroughly, because it will help you, and along with that you can also follow my notes. So please do the question answers which I give you, and any problem you can ask me. Okay, so till then, take rest and study well. Thank you.